In the integrand of this integral, there is an x squared minus 9, so that fits into trigonometric substitution case 3, where there is an x squared minus a squared. So in this case, the constant is equals to 3, because 3 squared is equals to 9, then a is equals to 3. According to case 3, you have to let x equals to a times secant theta, then I let x equals to 3 times secant theta. And then we are going to replace the dx with d theta, so we have to differentiate both sides. So dx is equals to 3 times the derivative of secant is secant times tangent, and then d theta. So this goes to that dx. Okay, now the x to the third, that is equals to, we raise the x to the third power, so 3 times secant theta, so x to the third is equals to 27 secant to the third power theta. And then what about the square root? The square root has x squared minus 9, so the x squared is 9, right? So that is 9 secant square theta, and then minus 9, and then this one we can factor out the 9. We have secant square theta minus 1, that is equals to tangent square, so 9 times tangent square, that is equals to 3 times tangent theta. So let's put all the components together. We have the square root is now 3 tangent theta. The denominator is 27 secant to the third theta, and then the dx is 3 times secant times tangent d theta. Okay, let's do some simplification and cancellation. So 3 times 3 is 9. 9 over 27, so that is 1/3, right? And then the tangent times tangent, that gives you a tangent square. Maybe I should put it right here. So 1/3. So we have a tangent square on top. And then the denominator, the secant to the third will be reduced by 1. So we have secant square theta and then d theta. And then the tangent and the secant, let's rewrite both. The secant, I would like to do a sine divided by cosine. Don't forget the square. The secant, I would like to let that be 1 divided by cosine square theta. So as you can see, the cosine square will be cancelled. So you have 1/3 the integral of sine square theta d theta. You can't just integrate this. You have to consider the double angle formula. So double angle if you look up the double angle formulas for online, they won't just give you the sine square. They will give you this. They will give you cosine 2 theta, that is equals to 1 minus 2 sine square theta, and then you have to isolate the sine square on one side by yourself. That is equals to 1/2, and then 1 minus cosine 2 theta. And then that is what we are going to rewrite. That is how we are going to rewrite the sine square. So the sine square is 1/2 and then 1 minus cosine 2 theta. So now we can integrate. First, we take the 1/2 out, so that is 1/6, and then integral 1 minus cosine 2 theta d theta. So the 1/6 stays there. The integral of 1 is equals to theta, and then the integral of cosine is equals to sine. So we have sine of 2 theta. What is left? When you take the derivative of sine, do we agree that by chain rule that produce a 2, right? So that's why we have to prepare the 1/2 to get rid of the 2. So the integration is complete. Now let's do the distribution. 1/6 theta minus 1/12 sine of 2 theta, and then plus c. We are not done. The problem starts as a x. We end up with a theta. So to go from theta back to x, you have to use the right triangle trigonometry. I am going to do that in a different color. So the right triangle trigonometry, let's draw a right triangle first, 90 degree, and then this is my theta. And then which line we have to grab? We have to go back to the very beginning and then grab the x equals to 3 times secant theta. So we have to pick this line, x is equals to 3 times secant theta. And then 3 times secant theta. That is secant equals to x divided by 3, and then secant is 1 over cosine. That is x divided by 3. If you take the reciprocal on both sides, cosine theta is equals to 3 divided by x according to the right triangle trigonometry. So katoa, the CAH, cosine is adjacent divided by hypotenuse. So adjacent is equals to 3, hypotenuse is equals to x. What about the opposite? So to figure out the opposite, you draw a right triangle yourself, and then this is A, B, and C, right? By Pythagorean theorem, a squared plus b squared is equals to c squared. You want to find b, then b is equal to, let's make the b look like a b. So the b is equal to c squared minus a squared, and then you take the square root of the whole thing, so that is x squared minus 9, right? Okay, what do we have? We have a sine of 2 theta. Okay, sine of 2 theta. Alright, okay, let's see how do we deal with sine of 2 theta. I can do first of all, the 1 over 6. Okay, we should keep that in red. The 1 over 6 theta. Actually, you know what? I should not write it like this. I should start with this. So we have secant. We have secant theta equals to x over 3. We want to know what theta is, right? So that means theta is equals to inverse secant x over 3. So the theta is done. And then the next step that you will have to do is you have to figure out the 2 theta, right? So the sine of 2 theta. So how do we get that? How about we do the rewrite? Sine of 2 theta. How about this? We have sine of 2 theta that is equals to 2 times sine of theta cosine of theta. How about this? So the cosine of theta is equals to 3 over x, and then the sine of theta is equals to SOH, right? So SOH, that is opposite over hypotenuse. So SOH, the opposite is the square root x squared minus 9. The hypotenuse is equals to x. So if you put all the pieces together, so the first we have a 1 over 6. So what the 1 over 6 is still a 1 over 6. And then the theta is inverse secant x over 3. Okay, the first piece is done. And then you have a minus 1 over 12. And then sine of 2 theta. So I use the double angle formula. The there is a 2. So this 2 goes right here. And then the sine of theta is the square root of x squared minus 9 divided by x. And then the cosine is 3 over x. And then you add c to it. So let's clean this up a little bit. You have 1 over 6 inverse secant x over 3. And then minus, so that will be a 3 over 6. So 3 over 6. So you have a 6, right? So the 2 and the 12. And then you have a 3. And then you have a x squared minus 9 divided by x squared, and then plus c. So the 3 over 6, we can change that to a 1/2. 1/2. How about this? We will just make this to be one line. 1/2, right? Okay. Then we extend the line a little bit. So this will be a 1. The half goes there. So this is the final answer of the given integral. So let me double check this. 1 over 6 inverse secant x over 3 minus the square root x squared. Yep, everything is there. All right, so that is the end of this problem. If you think I picked the best problem for discussion, especially in this one, I talk about how to deal with a theta that doesn't exist in the previous 2 problems, right? So in this problem, there is a theta in the final answer, and then I show you how to use the inverse trig function to rewrite the theta. So if you think the problem is good, the explanation is clear, give me a like, let me know in the comment below, share the video for me, subscribe to my channel if you are new to the channel. I will see you all in the next lesson. Signing out for now.